So part of today, you're going to hear me stress making sure you know which one you are finding, whether you're finding the measure. Well, actually, it's more of the measure of an arc versus the length of an arc. So that's going to be an important thing today, that you recognize the difference between those two, since they are measuring different things. But we start out actually with what are called central angles of a circle and how that relates to the measure of an arc on a circle. So a central angle of a circle is an angle that has a vertex at the center. That definition should make sense. Central angle, vertex is at the center. So in this diagram here, actually angle ABC could either be this angle or this angle, but I'm just going to write angle ABC. That would be the central angle that's drawn on there. Does anybody know how many degrees are in a circle? 360 degrees in a circle. So that means all of these central angles in a circle should have a sum of 360. Okay, so using that to answer the examples in example 4, finding x. So we have x here, we have this central angle is 130, this central angle is labeled as a right angle, so we know it's 90. So if I take 108, or I'm not sorry, not 180, 360, and I subtract 130, and then I subtract 90, that will give me what x is. So x would be 140. All right, so if we do that same thing for B, actually just, you can quick calculate it on your own. And I'll show the answer, just making sure you get the right thing. All right, you should get 145 for X for example B. Okay, so notice this is just thinking ahead to the quiz, the test for this chapter. So even something like this where you're just subtracting values, it's helpful on a quiz or test to actually write that down, because say you're just going too quickly, you type something wrong in your calculator, you get the wrong answer, and if I have no idea why you got that answer and it's just wrong, I'm not going to give you any credit for that answer. So at least writing down that you're subtracting, so I know that you know what to do, but maybe you just typed it in wrong, because I know that happens. You're not losing all of the points in that case. So it might seem like you don't really need to write that down, but that's helpful on a quiz at least, so that you're not losing all the points if something's wrong. So that's central angles. Then the main part of this lesson is the arcs. Again, the measure of an arc versus the length of an arc, and we look at measure first. So an arc of a circle, it's a portion of a circle defined by two endpoints. And a central angle, so one central angle separates the circle into two arcs. So it gives a diagram again, angle PQR. We have an arc here, so from P to R this way. We also have an arc here from P to R the other way. So we have two separate arcs. And what I have here, this is key for finding the measure of an arc. The measure of each arc is equal to the measure of its central angle. So the measure of an arc is equal to the measure of the central angle. So the measure of an arc, the units for that are degrees. It's the same units that an angle has. So just to give you an idea of what this means, so if I look, I'm going to look back up to this circle that was in example B. So that means this arc right here has a measure of 40 degrees because its central angle is 40 degrees. So that's what that is saying. If you know the central angle measure, you know the measure of the arc. So there are different types of arcs. There's minor arcs, major arcs, and then semicircles. So a minor arc is the shortest arc connecting two endpoints on a circle. So minor arc would be the shortest arc. So how I had talked about from the endpoints P and R, there's two arcs that connect to those endpoints. But to tell the difference between the two, the minor one is the shortest. And it will have then a measure that's less than 180, because the central angle should be less than 180, and it's equal to the measure of its related central angle. And then I want to draw your attention to how it's named as well. So notice how you name the measure of an arc. You put the M for the measure, and then you put the two endpoints if it's a minor arc. So actually, I'm going to write that here. So a minor arc is named using two endpoints. So you have the M for measure, you have the two endpoints with that little kind of arc symbol above it that shows the measure of arc AB. It's showing here that it's equal to the measure of its central angle, ACB, which would be measured as X according to that picture. So this is what it's talking about here. Then we have major arcs. So these are the longest arc connecting two endpoints on a circle. So the measure of a major arc will be greater than 180, and it's equal to 360 minus the measure of the minor arc with the same endpoints. So notice how a major arc is named. It's always named with 3 letters. So it's named with the endpoints, the A and the B, along with one point that is in between the two endpoints. So the major arc, if you want to make a note to yourself, named using 2 endpoints plus another point. Because that way, if you're just given, like find the measure of arc ADB versus find the measure of arc AB, you know this one should be the minor arc because there's only 2 letters. This one should be the major arc because there's 3. So that can help you out knowing which one to look at on the circle. And it says that is equal to 360 minus the minor arc measure, which would be 360 minus x. So basically you would want to find out what this angle was by subtracting x from 360, and then that arc would be equal to that central angle measure. And the last type is if you have a semicircle. I think you know what a semicircle is, half of a circle. So arc with endpoints that lie on a diameter, measure of a semicircle is always 180 degrees, half of a circle. And notice then a semicircle is also named with 3 letters, the endpoints along with a point that's in between them. So major arcs and semicircles are named with 3. So in this example set here, it says PM is a diameter of circle R. It says identify each arc as being a major arc, minor arc, or semicircle, and then find its measure. So if I am looking at arc MQ, is this a major or minor arc in the first one? Minor. There's 2 endpoints. So when I'm looking at this, so I see MQ, it's just making sure you don't go all the way around this way because that would be a major arc. That's not what it's asking. So it is asking for this one. So that is a minor arc. And then it is equal to the measure of its central angle, which is not given to us, but what would that angle be or how do we find it? Ethan? Yep. Okay. Yep, and that, yes, that works. So these would both be 90, so that's 180, add to 115, and then subtract that from 360. Or if you know that these two together are 180, these two together must also be 180, so you could just subtract the 115 from 180 as well, just a different way to get the same thing. So that angle is 65, meaning the arc is also 65. The arc is 65 degrees as well. So then the measure of arc MNP. And so there, when you give in 3, you just want to make sure that you're going in the right direction. Again, that you're going through N. And how would you classify that? Minor, major, or semicircle? Semicircle. So the measure of it is half of 360, 180. And then MNQ. So this whole arc, which we know is the opposite of the MQ we had found before, so that's a major arc. And so, Ethan, you had already kind of said what this was. Was that the 295? That would be the 180 and then adding the 115, or you could just subtract the 65 from the 360. All right, questions right now on minor, major, semicircles, arcs? Okay. So a little bit more about arc measures. So we define congruent arcs. These are arcs that are in the same or congruent circles. So they can be part of the same circle or congruent circles, but they have to have the same measure. So congruent arcs have the same measure. So then it says in the same circle or congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So it says here, this is more of a formula, not really an example, but it says if angle 1 is congruent to angle 2, that means the arc measures, so that would be FG, and then HJ would be congruent. So how you would write that, again, FG with an arc symbol above it would be congruent to HJ. And just like with segments, the order you put the variables doesn't matter. If you have them flipped around, that's okay. Or we could say the reverse of that statement. We could start with saying if we know that arc FG and arc HJ are congruent, that tells us their central angles are congruent. So just the opposite conclusion. So that would say angle 1 is congruent to angle 2. And then we'll also identify adjacent arcs and the arc addition postulate. So adjacent arcs, kind of like adjacent angles, these are arcs that are next to one another and they have exactly 1 point in common. So just think of adjacent as being next to. And then the arc addition postulate, the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So that should make sense. If you have 2 arcs next to one another, then if you wanted to find the measure of the whole thing, you would just add those together. So this is just finding more arc measurements. Why don't you just go ahead and see if you can find these measures on your own or working with those around you, and then we'll check them. So it's kind of just combining things we had just talked about. You might need to be combining multiple arcs to get an arc measure. let me know. Within these, because we're working with angles, you're reviewing some ways of finding angle measures from previous units as well. If you're stuck on finding something, let me know. But think about it this way. Okay. Check your answers. check your answers, and then I want to say a couple things that might be helpful if you're not already doing this. If you got the right answers and you didn't do what I'm going to recommend, then that's fine. Do what works for you. What I typically do with this type of problem is I first look at the circle, fill in the missing angle measures first. That's what I do. So I would look at this. There are vertical angles in here. So these two are both 63. Since this is 90, this would be a 90-degree angle. So then you can subtract 63 from 90 to get this 27. These two together form a line, so they should add to 180. So subtract this from 180 to get 117. So it is combining ways to find missing angle measures from chapters we have previously done, even first semester. But I would work on figuring out what the missing angle measures are so that when you're finding the arcs, then you can just combine whatever angles you need to. So that's my method for working through it, if that helps you. And then I did have some questions, good questions. I'm glad you asked. When you have a major arc or a semicircle and you have the 3 letters, you have to follow them in order. So if I have ABD, that's from A to B to D. So it's this whole thing. And then if you only have the 2 letters, that's a minor arc. So you're going the shortest distance between the 2. If there's only 2 given. Otherwise, if there's that middle letter, you have to be passing through that letter on the circle. So while you're doing your practice with that, if there's any questions, please ask like you're doing. We are going to be moving on now to arc length. So what I'm going to do is I'm just going to put like a squiggle through here because now arc length is different than arc measure. So again, make sure you are understanding the difference, and when you're asked for the measure of an arc versus the length of an arc, you're finding the right one, because measures of an arc are measured in degrees. Lengths of arcs are measured in length measurements like inches, centimeters, yards, feet, whatever it is. So an arc length is a part of the circle. You could also say it's a part of the circle / it's a part of the circumference. So I do have underneath that it's a fraction of the circumference, which I know is kind of saying the same thing, but it's part of the circumference. It's a fraction of the circumference. It's a length around. It's part of the length around a circle. So I have here, since circumference is a linear measure, arc length is also a linear measure. And again, what that means is your measurements are going to be in centimeters or in feet or in inches or in yards or etc. So those would be the units, not degrees. So the measure of an arc is in degrees. The length of an arc is in some other unit, some linear measure. Think of it as like a distance. So there's a formula for arc length. I am going to show you where that comes from, but I have the formula here in words and then in symbols. So since it is a fraction of the circumference, if you think of it this way, the word of in math means to multiply. So a fraction of the circumference means you're multiplying a fraction by the circumference. We learned the circumference formula, or rather we reviewed it yesterday, is either 2 pi r or pi times the diameter, if you have the diameter. And then the fraction you're multiplying it by is the fraction of the central angle out of the total 360 degrees that are in a circle. So where this formula is coming from, and normally you'll see it this way, they'll use L for the length, and they'll say L is equal to this, which I could put L is equal to this over here also. So these say the same thing, it's just this is in words, this is in symbols. So where this comes from is if I take my length of my arc out of the entire circumference, so the length of an arc out of the entire distance around a circle, I can say that's proportional to the central angle measure out of the entire angle measure of a circle, which is 360. So it's coming from this proportion, and how they're getting this formula is then they're multiplying both sides by the 2 pi r so that it cancels out here just to get this. So it is a proportion really that you're solving. This is just where it's already gotten the arc length by itself. So you take the central angle out of 360, you have that fraction of the circle that you're multiplying by the circumference to get the fraction of the circumference. So in 13, it says find the length of arc ZY. So again, directions, make sure when you see length that you're not giving me 75 degrees as an answer. You're not finding the measure of it, you're finding the length of it. So using this formula for ZY, and again, it's 2 endpoints, so it's my minor arc here. I know the central angle is 75 degrees. So I would take, I'll say this, ZY is equal to the central angle of 75 out of 360. And that is going to get multiplied by my circumference, which I know the radius is 4. So the circumference would be 2 times pi times 4, or 8 pi. And now this would get multiplied using your calculator, so you can round your answers for these. I think most of the problems on the assignment say to 2 decimal places, so we'll just round to 2. So typing this in, and this is another thing, making sure you can get the right answer on your calculator. So I would just type in 75 divided by 360. I could hit enter and just leave that in there, and then do times 2 times pi times 4, hit enter, and I should get 5.24 if I round to the nearest hundredth. There are 2 decimal places. So ZY, the length of ZY is approximately 5.24, and then it's inches since my radius was given in inches. So that is the length of the arc. The measure would be in degrees. Questions there? Okay, so just looking at another one, looking at B. So this is still same directions, finding the length of ZY, the minor arc ZY. So I'm finding this length here. And I know my central angle is 130. So I would say ZY will equal my central angle 130 out of 360 multiplied by, now because I have the diameter given to me, I don't have to do 2 pi r. Remember, you can also do pi times diameter. So that would be pi times 10, or 10 pi would be the circumference. And then I can type that in my calculator. So 130 divided by 360 times 10 times pi. And that would be approximately 11.34 centimeters. Okay, any questions on the arc length? Okay, so if you flip this over, I will pass out your practice for this, but just to make sure you're understanding these types of problems, it says use circle O to find the length of each arc. So what we just went through, round to the nearest hundredth. At least, why don't you just answer the first 2, just to get a couple of practice while I'm passing out the assignment, make sure you understand it. So at least answer 1 and 2. So you're finding the length of arc DE, given the radius as 2 meters, and then number 2, length of DEA, given the diameter of 7 inches.